Well, hello again, comrade subscribers. I just finished off the video on the QL. It's actually starting to get a bit muggy. Can't remember if I said so. Last night, when I started the video on the QL, it was quite muggy, 8:30, and it was about 31 degrees. So it's about lunchtime at the moment, and what are we on? 30. It was cooler this morning. It's now 31. Just over 31 degrees, I think. Remember, Wanson's Electricity House, Darwin. Call 3487. Keep cool. So it's starting to actually get a bit muggy again. But last night it cooled down. Got a cool breeze, and then we actually had a storm overnight. And then it was cool this morning, but it's starting to look grey, so I'll probably get another afternoon shower. Anyway, the Matra Alice, the French version of the Tandy TRS-80 MC-10. Finally, I got some replacement screws for the keyboard, I hope. So M2, 6mm pan head. I think that's what I needed. So the problem I had last time, was the keyboard didn't really work because there were only 2 screws holding it in. And from what I could see, they were M2 6mm pan head. So I finally found some. Unfortunately, local hardware store didn't have any, so I had to order these on eBay back in December, and they finally arrived. So let's see if they fit. So if I can get the keyboard fixed, then I can do some other things. So what else have I got? So I've got some peripherals. We've got RF modulator, which is so you can take your RGBS signal and downgrade it. We've got 16K RAM expansion, and we've got a joystick adapter, but not at the same time. And I also got a programming book. Not that I speak French, but for the Alice and the TRS MC-10. I thought that would be something interesting to have. So anyway, let's see if we can get this keyboard. Let's see if these screws match. We'll take one out and compare, hoping they do. Now it is actually starting to get humid again. I should be having a swim for lunch before I go back to work. Not doing this. I think the thread is a little bit different, but I don't think I'm going to really care, to be honest. That's the original. That's my replacement. Close enough, I think. Yep, I'm going to give it a try. Alright, there we go. So, I only had 2. I've now put in 8 more, so 10 in total. That just shows you. And much better, much better. So I think I might go jump in the pool quickly before my lunch break's over, and I'm going to I'll finish this after work. I think maybe it's cooled down a bit, I don't know, but yep, keyboard's fixed. That's what you need. M2 by 6mm pan head. Right, so that'll go back onto there like so. And the other thing I was going to mention that I'll be doing today, hopefully, if there's space, is replacing the 4K internal RAM with 8K internal RAM. See if that works. So just try quickly. We whack this down here. I'll need to remove those. I have to remove the 4K first, I think, to get a proper fit. Yeah, because that's kind of. I just want to see. I'm gonna have to put everything back. I'm gonna have to put this back together, like so. And no, there won't be enough room like that. No, so yeah, I'm definitely gonna have to take the RAM out first to see if there's enough room. The original way that this was done was this was soldered basically directly in because there's not much space. So, but I'm hoping if I go low profile enough, let's see. All right, swim, work, and then after work, we'll come back to this. G'day, comrade subscribers. So, still, I run into some issues with the keyboard actually. So, still some keys aren't working. So I need to do some troubleshooting. But before I do that, wifey's going off to England on Sunday, so she's got some cash, changed some cash over, and I've got to be quick because she doesn't trust me with this. But that's basically 100 Australian dollars there. The Aussie dollar's pretty shit at the moment. It's about 50 pence to the dollar, so that's $100. And yeah, so we've got Lizzie, and now we've got Charlie. So I just thought that was interesting. And they've gone to plastic money, like us Aussies here. They've finally caught up. So that's interesting. Anyway, and the passports are all changed. She's got her Aussie and UK passports, and they've got a big plastic. Can I show it quickly? I have to cover most of it up, but the new passports were interesting as well. Maybe we'll have a quick look at them. But yeah, there we go. I thought that was interesting. That's it. Yeah, back to this. All right, comrades. Let's get back to this. So, as I said, the keyboard isn't exactly working. I'm not sure why. Certain keys aren't working, like for example P. So I've tried a few, because I'm not sure. Let me just stand up. For example, what the orientation of these are. Do they go in like that, or do they go in like that? And they're a bit, well, they're probably only designed to be like inserted once and then that's it, not pulled in, pulled out. So they're starting to kind of unravel a bit. So what I've done with these ones in the past is that I've just replaced these with a wiring with a socket kind of on the end, and then just put some pin headers. If I can move this, some pin headers down here just to plug it in to make it a bit easier. But I need to figure out why certain keys aren't working. So this is a MC-10 schematic. So it's not the same because we've got an AZERTY keyboard, but for example P is one of the keys not working. So, but I'm not sure if A. So I might put my keyboard back together, hopefully without spilling all these little chiclet keys everywhere, and then go through and just mark off which keys aren't actually working, if I can remember which way these plugs go in. Yeah, so let's do that. So I have it put back in the way I think it is. It should be like that, as you can see the folds. But then again, obviously someone's been in here because there's screws missing. So maybe they've put it back in wrong. But let's try it now. Let's go back up here to my little holder. Put that there. Okay, and I'll set that up and capture some video output. Start capturing. So press A. No response. I was just looking at the schematic, and it's actually alphabetic. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So that's interesting. But yeah, so A is not working. Z is. E. R isn't. T. So it's like, yeah, okay. I think I might have to write down. So A, Z, E, R, T, Y, U, I, O, P. Because I was trying to do P for print out the memory. So yep, so A is not working, Z is, E is not working, R is, T's working. Oh, hang on, Dexy. R's not working. E is working. Z and, oh, okay. Start again. AZERTY. UIOP. So A doesn't work. Z works. E works. R doesn't work. T works. Y doesn't. U does. I doesn't. O does, and then P doesn't. Yep. And the @ symbol doesn't work either. Break. Don't know what break does, but it's not doing anything. But it should be doing something. Next slide. So what about 1, 1, 2, 3? Now that's interesting. So 1, we go above. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So 1 doesn't work. 2 doesn't work. 3 prints out everything. 3 prints out 1, 2, 3, 4, 5, 6, 7. Prints out the 7. 4 prints out 4. 5, 6, 7. Alright, so they work. 8 doesn't work. 9, 0. All of them work. Colon doesn't work. But that dash does work. That's interesting. Enter works. Alright. I should have just taken a photo of this and printed it out, shouldn't I? That would have been more scientific. I might do that. But you can see, if I go, I'll just go through them. Okay. So S is in line with the 2. So Z works. 2 doesn't work. 3 gives us the load numbers. S gives us, what does S give? Gives us P, P-A-R-S-T. Very interesting. Okay. All right. So K is giving us a whole lot of junk as well, or a whole lot of letters. So it could be I don't have that plugged in correctly. All right. We're going to have to do some more research. Let's start recording that. All right. I'm not really following how these key switches work. I want to pull one out just in case I need to clean, but it doesn't really. I'm a bit worried if I pull one out, I'm not going to be able to get it back in again. So I might actually desolder. So you can see here, so there's actually continuity between these pins and between these pins. But then when I press it down, I'm not seeing any change in the I'm not seeing any continuity between these two. Unless I'm not, it's not exactly easy to hold the probes, but I'm a bit confused how these actually work. So I might desolder one just to have a bit of a closer look. And to aid that, this arrived yesterday from Amazon, Engineer brand. So this is their SS03 solder sucker. So I actually saw this on a YouTube quick, and it's Japanese, as you can tell by text everywhere. It looks pretty good. So I do a lot of desoldering, and I'm not really happy with the stuff I've got. So I thought I'd give this a try. The benefit is that it's got this flexible. Well, I'll open it up. So the one I saw was the SS02, but when I was looking on Amazon, they had this SS03. So it was 49 Australian delivered. Actually, I can just, there we go. So this is all the instructions here. But yeah, so the benefit apparently, so it comes with 2, whatever these are, silicone. So two different diameters, and you just pull it off here, I guess. So there's a short one there. Yeah, it pulls off like that. And then put this one on, I guess. And because it's flexible and it's heat resistant as well, so it's not going to melt. So I know with the traditional, it's one-handed like that. So I thought I'd give it a try. So I do have the traditional one there with like the hard plastic tip, and this apparently, you can kind of make a much better seal to suck all the solder off. So let's give it a try and remove one of these key switches. So I think I might try the P. So this is actually, I guess this is the same as the MC10 because it's actually QWERTY. But we know that P doesn't work, so it's a bit confusing, but they are mounted, okay, so the pins are vertically. So for the P, so I'll just get my poker. So for the P, we want to desolder those two and these two. These two are for the next row down. These two are for the next row up. So it's these two here. So like I said, so there's continuity between there and between there. But when I press the key down, there's no like I'm not seeing any continuity there. So I'm just not entirely sure. So anyway, so I'm going to I'll reflow the solder first, and then try the solder sucker. 1, 2 as a practice. I think it's going okay. So let's try this third one. So I've got it pressed down. Okay, heat it up. And push this on top. So I sucked a bit of solder off. Try one more. Alright, mind you, this is the first time I'm using this, so... so I normally use flux as well, don't I? I think that's not too bad, but yeah, normally I'd put a bit of flux on there as well. Makes things a bit better. But I think maybe that's good enough to get them out. Let's see. It was. That was it. That worked really well, because when I get back to the UMPKR, the Soviet homebrew computer, everything's soldered in, so if I have to replace anything, I'm going to have to desolder it. But that's the actual key switch there. So it's like a tactile switch, but the rubber dome. So I'm going to do some more continuity testing to try and figure out how it's supposed to work. I managed to verify that this key switch is actually working. So this is the P that wasn't working when it's in the circuit. So there is continuity between the far ends, between the far end pins normally. So between those two pins and the other two. But there is no continuity between these neighbour pins here. Unless you press the button. I'll hold the button down like this. And then there's continuity. Sorry. I'm trying to prove it to you, but it's very awkward. So you can see there is continuity there now. So this key switch is actually working, which means I'm assuming that the plug into here is the problem. I have actually tested also the continuity between this and the ends, and that's fine. There's no break in this wire here. So there's some issue, I think, with this plugged into that. So I don't think I need to pull this apart because it is working. So I can put it back in. And I reckon I'm just going to replace these and that and give that another try. So yeah, I'm pretty happy with this. Worked pretty easily. First one done. So I'm going to angle it that way, so I can plug the wires in like so. That's the plan. Plug the wires in that way to the keyboard. So that should give me, hopefully, room so I can later try the RAM expansion. And I think this one here, I'll just have them poking down this way. So let's give that a try. Oh my god, how good is that? So using the this Engineer solder pump, just reflowed the solder, and then I went through and one of them I had to do twice, but that was it, and then I just came off. This is awesome. Where have you been all my life? I was just thinking with these other ones here, they're obviously, I think they're probably a bit too long, so you could probably cut them to size. That's probably what the instructions say. Anyway, so that one's done. They're both 8x8. One of them actually only needs 7. Which one's that one? But I'll still do, so jumper 4. Huh? Jumper 4? Jumper 4 and jumper 4. Okay, jumper 5 and jumper 6. Anyway, one of them only needs 7. The other one's 8. Doesn't matter. Doing 8 on both. So this one here, pointing this way. And I'll probably angle them as well, but that's the plan. And we'll see if that makes any difference. Alright, let me get this done. Now the keyboard's done very, very quickly using the Engineer SS03 to get those off. Now to put these on, let's see if that makes any difference. Probably need to shorten them, won't I? Let me tidy up. Yeah, I know. Half of it's done. So I got some hot glue there just for the mechanical strength. So that sits like that, doesn't it? So that will actually plug into that one there. Black is pin 1, so that'll go in like that. Like so. Something like that. I've changed the, oh yeah, that's still warm. I've changed the regulator as well. Problem is I'm a bit wary. Yeah, I might have to figure that out. Put some Crapton tape down there. Anyway, time to do the other side. There's my completed board. Some hot glue on either side. And what's pin 1? Unfortunately, it's doing exactly the same. So this is what it looks like plugged in. Much easier, much easier. And I got this one back to front, didn't I? Pin 1 is purple, like so. So there we go. So just have the cables in here somehow tidily, like that. But it's doing exactly the same thing. So for example, you press the number 3. Now this is the MC-10 schematic, but you can see you press the number 3 and you get 0, 1, 2, 3, 4, 5, 6, 7. So that's all on the same row. So it could be something, well, that would mean that all of these are shorted, wouldn't it? If I press 3, press 2, I get nothing. So yeah, so this is using an MC14503B, but because this is a Matra Alice, we don't have that. I think this is the equivalent, that one there. So I think it's just a buffer anyway, isn't it? In and out. So this is going to require a bit more troubleshooting because there is obviously some fundamental issue with it. And you can see that they've probably pulled apart the keyboard and lost half the screws trying to fix it, but the issue isn't with the keyboard. The issue, I think, is with the circuit board, or one of the ICs, I think, maybe the buffer or something. But that's fine, because I wanted to do this anyway because I didn't like those other things. So that'll go in like that. So some more troubleshooting to be done. I think I'll hook it back up again. I think I'll take a photo of the keyboard actually and then make a proper diagram to see what exactly is going on. Something strange. Right. I've been doing some tinkering and some investigations, and I've got a summary. So this is a summary of what does and doesn't work. So the red keys don't work at all. Keys with nothing on it, they do work. Keys with the yellow circle produce strings. So the interesting thing is when you look at that on the keyboard schematic, so this is for the MC-10, I've modified it So it's basically A, B, C, D, E, F, G, H, I, J, K, but I've modified it so, because obviously we've got a Q where A should be, and various other bits and pieces. So the interesting thing is that the most of the ones that produce a string are in the same column, which is this KR3 signal. The ones that don't work are both in this column here. So this neither of these columns work. So I'm just trying to get my head around. It's pretty simple. The rows are connected via a pull-up resistor to this non-inverting buffer, which is then connected to the CPU, the 6803 data lines, D0 to D5. The columns are connected directly to port 1 on the CPU. I think I've got the CPUs here somewhere. Here we go. So P10 to P17. So this is port 1 on the 6803. So this is the columns, and this is the rows coming in via a buffer. So yeah, I'm trying to figure out. So there is something in common, right? So there is something common here. Neither of these ones work. These ones produce, so basically when you press C, you get all the characters on this row. When you press K, you get all these characters on the row. Same with S, same with 3. But when you press, I think it's comma or M, both these have the same effect. You get all the characters on this row. So pressing the yellow, you get all the characters on the row. These ones don't work at all. So it's pretty simple. So I'm a bit. Let me just turn the machine off. So I'm thinking I might see if I can connect up my logic analyzer to the pins here. But if we look closely, so this is the CPU here. This is the port 1 pins here, and I think the data lines are up here. This is the non-inverting buffer, so it's a HEF 40097, I think it says. And this is the pull-up resistor here. So obviously, let's just disconnect all that. Let's get the board out. Have a quick look. So this connector here, these are the rows which goes to the pull-up resistor, goes to the non-inverting buffer, which then goes up to here, and these are the columns. So you can see the columns here. No tracks on that side, but they go down, I guess, and then down to here. So I have checked the continuity. I'm pretty sure I will double check, but definitely there's continuity here and the data lines. I will double check the continuity for the columns, but that's pretty much all there is to it, just these two chips. So could it be the CPU at fault? I'm not sure. Could it be the buffer at fault perhaps? Just a reminder, looking at the diagram. So columns go off to port 1 on the CPU, rows are pulled up and then go via a buffer to the data lines. So I will just check the continuity. I have checked each pin. There is no shorting. There's no shorting between the pins, but I'll just double check the continuity. I can't see anything wrong with it. There we are. Well, good evening. It's been a while. Just so muggy every day. So it's time is it now? 8:45 at night. It's threatening to rain. So what's that? 32 and a half degrees. Ugh. It's just tiring. Anyway, I'm a bit stuck with this keyboard behavior on the Alice. So I've had a look I've got the analyzer hooked up, and I've had a look at the buffer, and I'm happy with the buffer. That seems to be basically what goes in, what comes out. So everything is high because everything's pulled up to 5 volts. You press a key, it goes low. Except for the keys that don't work, they don't produce any effect. The working keys do, but the particular line goes low. So that's interesting. So now I'm hooked up to the port 1 on the CPU, which handles the columns. And there's some interesting behavior there. I'm not sure what what I can do. You know, if it's the CPU that's at fault, then obviously I'm going to have to get a new CPU. So I've got, I'll have a quick close-up. So I've got I've got the port 1, so that's all the columns. So that's all the columns there. And then I'm going to concentrate on, say, the numbers 0, 1, 2, 3. So I'm going to concentrate on that row. So I've got this J66 connector also connected up, the in and the out, which is those two connectors there. And I've got the analyzer set up on the screen, and I'll have the output down in the corner there. So I'm going to just screen record that, I think. Okay. Hey, I've been doing a bit of fiddling. I think I might understand how it's working. So the CPU is pulsing these columns, which are pulled high. So if it goes low, so we pull the column low, or we output, if we go low, and if we press a button, then the row goes low, and then we can detect it, I think. I think that's what's supposed to be happening. Because, right, if I start screen recording, okay, record, press play. Okay, so I think that's what we can see for KR4. Let me just stop that. So 4, 5, 6 and 7. So 7, 6, 5 and 4. Alright, doesn't explain 3 though. This one's although this is the one that's misbehaving as well, isn't it? That's the one that's producing multiple characters. Is the KR3 mostly. Okay, and then KR0112, that's the leftmost columns which don't work at all. So they are low all the time. Alright, so if I press play again, zoom out. So if I press 0, so KR0 is going high, which makes sense because we're completing the circuit because the row is high. So the row is high, so the port goes high, but it's not being detected, so it's not printing any character. 1, same with 1. 2, because the row is high. So it's just being pulled high. So we're just pulling. So the port's just being pulled high, but as a result, it's not being detected. So 3 is the one that was misbehaving. It was printing multiple characters. 4. Okay, now you can see on the J6 we're getting a result. So maybe 3 isn't working at the moment either. That could be because we're not seeing any change in J6 in the row. 0, 1, 2, 3, but we do for 4. And I think 4 is being printed. So, but interesting, why Why are other columns affected when we do 4? 5, 6. Well, I guess it doesn't really matter, does it? As long as the row is detecting it. 6, 7. Alright, let's start recording again, and then that's the end of the row. Yep, alright. So 0, 1, 2, 3, 4. So I'd say 3 is not working at the moment either. Well, it's not really working properly anyway because it's printing out 0, 1, 2, 3, 4, 5, 6, 7. Yeah. So the problem is the port, perhaps. Let me stop recording. So I wonder if the problem is the port on the CPU. Here's the CPU. Maybe these ports should be getting toggled, and they're not. Faulty CPU? Could be faulty CPU. Or something else on those ports, on those lines, that's causing them to be pulled low. Maybe. Alright. So hopefully you understand my my confusion. So maybe it is a... I'll have a closer look. Let's just power off. Maybe it is an issue with these first 4 ports, these first 4 lines. That's why that's why it's not working properly. So I'll take all this off and have a close look, but I don't think we have to order. I'll order some spare CPUs from I think Unicorn Electronics. They've got some for $8 or something. What do you think? Am I on the right track, or what else should I check? Let me know. Thanks for thanks for sticking around this long. Bye for now.